We are the principal astute life in the known universe. Imagine that we are the fundamental place where there is information in this inestimable framework. Cosmologists all throughout the world are in awe of this ever-evolving discovery. The James Webb Space Telescope, JWST, has captured the subtle shimmer of city lights an unfathomable 7 trillion miles away from Earth, outperforming all expectations. This amazing achievement does more than just broaden our perspectives in terms of what we know about the universe. Speculation goes wild as scientists pore over the data, searching for signs that could open the secrets of these puzzling, glorious lights. The ideas are astounding. Could we be in good company in the universe, with the universe teeming with life and activity quite far outside our capacity to comprehend? Is it possible that these far-off lights show the presence of extraterrestrial societies? What does this mean for our understanding of the possibility of life in the universe beyond Earth? Join us as we examine how the James Webb Space Telescope just saw city lights 7 trillion miles away. Launched into space on Christmas Day 2021, the James Webb Space Telescope was designed to surpass the deeply ingrained Hubble Space Telescope in obtaining remarkably sharp photos of newly discovered brilliant objects, planetary systems, and more. A primary goal of the JWST is to concentrate on the development of the first galaxies by investigating the distant regions of the universe. This is pragmatic because the journey time of light throughout our universe is billions of years. When the JWST collects light, it captures these objects exactly as they were billions of years ago. Space scientists measure distances in light years, which is the greatest distance light can travel in 1 year. To address this, the JWST's primary practical focus was a significant field picture, released on July 11, 2022, by U.S. President Joe Biden during a speech at the White House. As the Hubble Space Telescope focused on a single area of the sky for 10 straight days, starting December 18, 1995, it had already made notable discoveries in the significant field. The Perigin was just a small spot, making up around 1/1,000,000th of the entire sky. Most of the 3,000 previously unknown objects discovered by Hubble were enormous galaxies located billions of light-years away, with its center of focus on the SMX 0723 galaxy group. The JWST's significant field covers a similarly small region of the sky. The galaxy SMX 0723 is 4.6 billion light-years away, and the more distant galaxies behind it are intensified by strong gravitational fields. The formation of these galaxies is distorted into enormous twists due to the gravitational forces at their strongest points. It was estimated that it took the light from a distant galaxy 13.1 billion years to reach the telescope, highlighting how far back in time the JWST is able to capture these objects. The light we see today is stretched out as the universe continues to expand. The chief objective of the JWST has expanded visible light from their stars into the infrared, allowing astronomers to directly compare JWST's images of distant galaxies with those taken by the Hubble Space Telescope and other observatories. By gathering data at these frequencies, scientists can observe how galaxies evolve over vast periods of time, enhance and merge into the structures we recognize today. What's even more astonishing than the sheer number of galaxies the JWST has observed is how quickly it captured these images, in just hours, compared to days for all previous telescopes. Wherever it looks, it cannot help but focus on galaxy clusters. One of the major accomplishments of the JWST was capturing images of several galaxies designated VV1191. These images helped scientists focus on how the light from one of the galaxies changed as it passed through another. The results of the investigation will reveal the properties of the intervening astronomical structure. Furthermore, it seems that the JWST may have recently made another remarkable discovery: auroras on a planet that doesn't have a host star. The announcement of the potential discovery of auroras on a specified brown dwarf was made on the official JWST website. The lack of a host star and the frigid temperature make it difficult to pinpoint where the energy in the upper atmosphere is coming from. However, the fact that the object is emitting methane is significant. Just as auroras on Earth are caused when energetic particles from the sun interact with our planet's magnetic field, creating a spectacular light display, similar auroras on Jupiter and Saturn are caused by the solar wind. However, the brown dwarf in question does not have a star, so its auroras remain a mystery. Everyone's attention continues to turn to Proxima Centauri, TRAPPIST-1, and other nearby star systems. Just 4.4 light-years from Earth, Proxima Centauri and TRAPPIST-1 remain focal points for astronomers. With the detection of water on some exoplanets, the possibility of life beyond Earth cannot be dismissed. Could we finally find evidence of extraterrestrial life? Just last month, the JWST discovered an exceptionally massive black hole. This colossal black hole is 40 million times the size of the Sun and has been there since the beginning of the universe. This monster is rapidly consuming everything in its vicinity, which has led to the discovery being reported by Dr. Lucas Fu and Professor Alistair Zittrain of the Ben Gurion University of the Negev in Israel. According to their findings, this supermassive black hole is roughly 700 times heavier than the Sun and is consuming everything in its path, but fortunately, it is located 129 billion light-years away, so it poses no threat to Earth. However, it is moving closer, consuming everything around it at a rapid pace. The red color seen from the black hole comes from its location in a dense area of cosmic dust that prevents light from passing through. When the JWST started sending back its initial data, scientists were thrilled, particularly with 3 small red dots that appeared. Initially, they thought the dots might be connected to a black hole at the center of a galaxy. Black holes of this magnitude are constantly gathering material due to their red appearance, but the discovery revealed that the black hole was much larger than expected, far exceeding the size of many other known cosmic structures. The JWST has also shed light on how supermassive black holes in the early universe evolved, providing insight into their development and their relationship with host galaxies. Meanwhile, the James Webb Space Telescope continues to make strange and exciting discoveries. Each day, the telescope reveals the extraordinary lights of distant stars and planets, shining through the vastness of space. For example, a peculiar image captured by Webb last month showed something that resembled a question mark in space. This was captured while observing 2 young stars, about 1.47 light-years from Earth, in the Herbig-Haro 4647 system. At first, the strange mark seemed like nothing more than a curiosity, but upon closer examination, scientists found that the question mark-like shape could be related to the interaction of nearby galaxies. With more investigation, the JWST might reveal that these galaxies are connected in ways previously unseen. With the flood of faraway celestial objects uncovered by Webb, scientists are now turning their attention to a particular set of Earth-sized planets that could hold the key to finding extraterrestrial life. One of the greatest challenges in space exploration is the lack of evidence for advanced extraterrestrial life, despite the high likelihood that such beings exist. The planets in question are located 40 light-years away from Earth, orbiting a star known as TRAPPIST-1. This star has 7 planets orbiting it, and NASA has been exploring these planets for their potential to host life. The James Webb Space Telescope has already begun assessing these planets, and its findings are providing new insights into their conditions. TRAPPIST-1 is particularly noteworthy because its planets are Earth-sized and located in the habitable zone, where liquid water could exist on their surfaces. NASA's previous discoveries using the Spitzer Space Telescope had already identified 7 Earth-like exoplanets around TRAPPIST-1. The JWST has now provided the first-ever measurement of light emitted by one of these planets, TRAPPIST-1b, which is one of the smallest and coolest of the group. This is a groundbreaking achievement, as no telescope before the JWST had been able to measure such faint infrared light from such distant planets. Despite these exciting discoveries, the planets around TRAPPIST-1 are still far out of our current reach, located 235 trillion miles away. These planets orbit a star that is much smaller and cooler than our Sun, known as an M-dwarf star. M-dwarfs are more common than Sun-like stars in the Milky Way, and they are believed to have a higher likelihood of hosting rocky planets. However, M-dwarfs are also more volatile, emitting intense flares that could potentially harm any developing life or alter the conditions on planets orbiting them. The JWST has provided detailed measurements of TRAPPIST-1b, allowing scientists to refine their understanding of the planet's atmospheric conditions. Despite these advances, the conditions on TRAPPIST-1b suggest that it may not be as hospitable as once hoped. The planet is tidally locked to its star, meaning one side is always facing the star, while the other remains in perpetual darkness. While the JWST has measured the temperature of the planet, it has also ruled out the possibility of a stable atmosphere, further complicating the search for life on these distant worlds. The James Webb Space Telescope continues to make groundbreaking discoveries as it explores the far reaches of space. With its advanced infrared capabilities, it is poised to answer some of the most pressing questions about the universe, from the possibility of extraterrestrial life to the formation of galaxies. Its observations are providing new insights into the conditions of distant planets and the evolution of cosmic structures, and it will undoubtedly continue to shape our understanding of the universe for years to come as the James Webb Space Telescope, JWST, continues to unveil the mysteries of the cosmos. Its groundbreaking discoveries provide insights into the very nature of our universe. One of the most intriguing areas of research enabled by JWST is the study of exoplanet atmospheres. The telescope's ability to analyze the composition of these distant worlds has already yielded valuable information about their climates and potential habitability. For example, in the case of TRAPPIST-1b, although the planet's atmosphere was ruled out as being capable of sustaining life, other exoplanets in the same system may still harbor environments suitable for liquid water. This is a key condition for life as we understand it. JWST's infrared capabilities are crucial in this research. Infrared light allows astronomers to peer through cosmic dust clouds and gas that often obscure visible light, revealing the hidden structures of forming stars and galaxies. This capability makes JWST an essential tool for studying the early universe, offering glimpses into the first galaxies that formed just a few 100 million years after the Big Bang. By capturing light from these ancient galaxies, the telescope is helping scientists understand the origins of cosmic structures and the processes that led to the universe's present state. In addition to studying galaxies and exoplanets, JWST is also advancing our understanding of star formation. The telescope's sharp resolution and sensitivity enable it to observe the birthplaces of stars in unprecedented detail. These regions, known as stellar nurseries, are often shrouded in dust and gas, but with JWST's infrared technology, astronomers can penetrate these obscurations to reveal the raw processes that drive star formation. For example, the JWST has captured the intricate details of the Orion Nebula, a well-known stellar nursery, revealing complex structures in the gas and dust that form new stars and planetary systems. These observations will help scientists refine their models of how stars and planetary systems evolve over time. One of the more exciting possibilities in the study of star formation is the potential for discovering new types of stellar objects that have never been seen before. JWST's ability to detect faint infrared signals makes it particularly adept at identifying objects at the farthest reaches of space, where stars and galaxies are still in the process of forming. By studying the light from these distant objects, astronomers hope to learn more about the conditions of the early universe and how galaxies and stars were able to develop so rapidly after the Big Bang. JWST is also providing insights into the nature of dark matter and dark energy, two of the most mysterious components of the universe. While dark matter cannot be directly observed, its effects can be seen in the way galaxies move and interact. By studying the gravitational lensing caused by dark matter, the telescope is helping scientists map its distribution across the universe. Similarly, dark energy, which is thought to be responsible for the accelerated expansion of the universe, remains an enigma. JWST's observations of distant supernovae and galaxy clusters will allow researchers to test existing theories about dark energy and refine our understanding of how it influences the large-scale structure of the universe. The ability to peer deeper into the cosmos also has significant implications for the search for extraterrestrial life. While the detection of life beyond Earth remains elusive, JWST's ability to analyze the atmospheres of exoplanets has opened up new avenues for exploration. By examining the chemical signatures in the atmospheres of distant planets, scientists are searching for biosignatures, gases or compounds that might indicate the presence of life. For instance, the detection of oxygen, methane, or carbon dioxide in the atmosphere of an exoplanet could suggest the possibility of life, as these are the types of molecules often associated with biological processes on Earth. Although no definitive biosignatures have been found yet, the JWST's ongoing observations are bringing us closer to answering one of the most profound questions in science. Are we alone in the universe? Furthermore, the JWST's contributions to our understanding of planetary science are not limited to exoplanets alone. It has also provided valuable data about our own solar system. For example, JWST has observed the outer planets, such as Neptune and Uranus, offering new insights into their atmospheres and weather patterns. The telescope's observations have revealed details about the seasonal changes in the atmospheres of these ice giants, as well as the structure of their rings and moons. The ability to study these distant planets with such precision will help us understand the broader processes at play in planetary formation and evolution. In summary, the James Webb Space Telescope is revolutionizing our understanding of the universe. From the study of distant galaxies and star formation to the hunt for extraterrestrial life, its discoveries are reshaping the field of astronomy. The ability to see farther back in time and to study the faintest objects in the universe is allowing scientists to answer fundamental questions about the nature of the cosmos. As more data comes in, the JWST will continue to challenge our perceptions of the universe, offering new discoveries and insights that will shape the future of space exploration for decades to come.